In this tutorial, we're going to take a look at some strategies for factoring, different kinds of factoring that will be useful in this course, the 3U math course that I'm teaching here, and in factoring when you need to find common denominators, we need to simplify rational expressions, that kind of thing. So the first thing says check for common factors. That's always what you should look for first. If you can find something in common to all the terms and factor it out, it'll make the rest simpler. So if you look at 3, negative 12, and 15, 3 divides evenly to all three of those numbers. And then notice they all have powers of x. So it's the smallest common power that you can factor out. Okay, x squared is the smallest common factor of x here, or power of x. So we can factor a 3x squared out. Now what you're doing to get the what's left in the brackets here is factoring is the same as dividing. So what we're really doing is dividing each of these by the 3x squared. So if I divide 3x to the fifth by 3x squared, that's where the x cubed comes from. See, the 3's divide out. 3 divided by 3 is 1. That's why there's a coefficient of 1 right here. And x to the fifth divided by x squared would be x cubed. Remember, you subtract the exponents. So if I divide this by our common factor again, the 3x squared, then we'll get negative 12 divided by 3 is negative 4, and 3 minus 2 would be 1, so it's just x to the power of 1, or after the 4, negative 4. And then lastly, we divide this by 3x squared. Of course, the x squareds divide out, and 15 divided by 3 is just 5, and we've completely factored that. So always look for a common factor. Step 2, factoring by grouping, and steps or cases here. I'm going to take a look at several of them. Factoring by grouping is really kind of like bigger common factoring. So that's why I'm doing that one here, and we'll get into the trinomial stuff and perfect squares on another page. So factoring by grouping is always if you have an even number of terms. Now if you only have 2 terms, it's just going to be common factoring. Factoring by grouping is if there's 4 terms, 6, 8, 10, 12, 16. I mean, it's you will generally get into like 12 or 16 terms, but I'll take a look at an example with 4. That's probably the most common you'll see here, but I'll do one with 6 as well. And so what you're looking for is a common factor in the first 2 terms and the last 2 terms. And I guess if it's 6, it could even be in the first 3 and the last 3, but we often will look first like the first 2, the middle 2, and the last 2, that kind of thing. So if we look at these first 2 terms here, 4a squared minus 6ay, there's a common factor of 2a. 2a divides into both those. 2 goes into 4 and 6, and you see we have powers of a here. The lowest common power is 1, so that's why we can factor 2a out. So I'm going to divide both of these terms, but I'm going to stop right there by the 2a because I'm only factoring the 2a to these 2. Now, 2a actually does factor out of negative 14a, but I'm grouping first 2, last 2. So if I divide 4a squared by 2a, I get 2a, and divide negative 6ay by 2a, I get minus 3y. Close the bracket. Now in these terms, we can factor a negative 7 out of these 2 terms. So I'm going to factor a negative 7 out of those. So if I divide negative 14a by negative 7, I get a 2a. And if I divide 21y by negative 7, I get minus 3y. Now, a mistake here that you see people make sometimes, this isn't really common, I guess, but some people might tend to think, well, okay, I'm factoring a 7 out of here. Let's put a 7 here. Okay, so let's say they didn't do this. Okay, scratch it over a moment. So if we factor a 7 out of these 2 terms, 7 out of negative 14a, there would actually be a minus 2a. And 7 out of 21, we would have a 3y in the end. Now, notice that this, although pretty similar to this, they're opposite signs. You see, this guy here, when I did it correctly, was exactly the same as what's in here, and that's exactly what you want. Okay, so if there's a negative right here, then factor a negative common factor of those last 2 terms. Let's get rid of that. There we go. So now notice that these are the same. So 2a so even though it's a binomial, not just a monomial like the 3x squared, 2a minus 3y is common to both parts. So that binomial is actually a common factor. And so we factor it out, and what you're actually doing is this. When we factor it out, just like I divided by the 3x squared above, that you're really doing is dividing the first part by 2a minus 3y, and the second part by 2a minus 3y. So what really happens is that divides out and this divides out, and what you're left with is 2a minus 7, and so that's why that's the other binomial factor. And so I'm going to do an example with 6 here as well. So again, I'm going to look at what's the common factor in the first two terms. And see, 5 and 3, common factor is 1. But there's an x cubed and an x squared here. So I can factor an x squared of those. So let's factor an x squared of those. So again, 3 minus 2 will be 1. X squared factors out here. So there's really just the minus 3y left. And in the middle two terms, again, 5 and 3, no common factor there, but except 1. But there's a b here, and there's also a y and a y squared. So I can factor a by out. So plus, now don't forget the plus here. And so if we factor a by out of this, the b and y are gone. It's just 5x. And see, the b has been factored out, so minus 3, and then y squared divided by y is y. And on the end here, again, remember negative here, so I want to factor a negative out just like with the negative 7 there. Negative 6 divides into both these. There's no variable common factors because it's just an x and just a y, but we can factor a negative 6 out. So dividing this by negative 6, I get 5x, and this by negative 6, I get minus 3y. And so notice that what's in the brackets is the same. And so this factoring by grouping is going to work. Now, if those things weren't the same, then I couldn't factor it. So 5x minus 3y factors out. And of course, if we divide it out here, here, and here, what's left is the x squared plus by minus 6. So that's the other, in this case, a trinomial factor. So that's factoring by grouping. So the examples on this page are really pretty similar because it's really, really common factoring. We call it factoring by grouping when it's bigger than just a monomial, though. This page we're going to take a look at trinomial factoring. A lot of people call this a simple trinomial and this one a complex, simply because there's a number other than 1 here in front of the x squared, where this has a 1 only. So factoring x squared plus bx plus c, we're looking for two numbers that have a sum of this number here. Now just the b, not bx, just the b. And a product of c, this number in the end here. So with this example here, the sum would be 2 and the product would be negative 15. And so we're going to factor this, we're trying to find two binomials that this will factor into, that if we expanded this we would get x squared plus 2x minus 15. So the sum is 2, the product is negative 15. And so we look for a pair of numbers, two numbers, that multiply negative 15. Now there's an infinite number of numbers that have a sum of 2. 1 and 1, 0 and 2, 10 and negative 8. Okay, so, but narrow it down by looking at the product first. There's only a finite number of numbers that multiply to negative 15. And of course, we're talking about just integers. Okay, so don't worry about decimals or fractions. And the numbers would be negative 3 and 5 in this case. So negative 3 and 5 multiplied negative 15, and they do add to 2. The 3 has to be negative, the 5 positive because it adds to a positive. We can't put a negative 5 here and a positive 3 here because that would add to negative 2. But we want it to be positive 2 because there's a plus here. So what we do with the negative 3 and 5 is this going to be x minus 3, and this is going to be x plus 5. And if we could check x by multiplying together, x times x is x squared. Actually, let me just do that. You always check any factoring by expanding. So x times x is x squared. X times 5 is 5x. Negative 3 times x is minus 3x. And negative 3 times 5 is negative 15. And the middle two terms, or the like terms, 5x minus 3x is 2x. Minus 15, so we do get exactly what we started with, which is great. That's exactly what we want. So step 4 here, factoring, and this is going to apply to any trinomial. In fact, you could use this kind of factoring on this one. It's just that if you remember there's only a 1 here, then this method for factoring is shorter. But this will work on any trinomial, including this one here. So for factoring these, we're looking for two numbers still of a sum of b. That part's the same, but the product is ac, the a and the c here. You see, a is actually 1 here. 1 times c is just c. So really, this is a simpler version of this. So 5x squared plus 18x minus 2 is what we're factoring. So the sum would be 18. And the product would be negative 40, because 5 and negative 8 multiply negative 40. And those numbers are 20 and negative 2. There's lots of pairs of numbers that multiply negative 40, but that's the only pair that also add to 18. So what we do with these, and this method is actually called decomposition. I'm going to show you another one as well. So we rewrite this, and we break down the middle term, the 18x, into, and here's where the 20 and negative 2 are used, into 20x minus 2x. See, 20x minus 2x is 18x, so this is equivalent to this. So now we do factoring by grouping, like we did the second bottom sort of half of the last page. There's a common factor of 5x in these two terms. So we're going to factor a 5x out of here. So we factor 5x out of this, we get x. 5x divided into 20x gives us a 4. And then the last two terms, there's a common factor of negative 2. So we factor negative 2 out. Negative 2 divided in this gives us x. Negative 2 divided in negative 8 gives us a 4. So again, notice that these are the same. So x plus 4 is my common factor, and then 5x minus 2 is the other factor. Now, I said I was going to show you another method. And this is called the Australian method. And what you do here, you still need the 20 and the negative 2. Okay, so this is 5x squared here. So what I'm going to do is I'm going to write 5x. I'm going to actually write two binomials here. And I'll write a 5x at the beginning of each of them. Now, 5x, not 5x squared. Okay, so, and I'm going to put the plus 20 in one and the minus 2 in the other, and it really doesn't matter which. And then I'm going to put it over 5, 5 being, again, the a number. Now, what's in the 5x plus 20, there's a common factor of 5 here. So I'm going to factor a 5 out, and I would get x plus 4. So scratch this guy out because it's factored now. And so this 5 divides into this one. And so here's my x plus 4 factor. And here's my 5x minus 2 factor, which is exactly what we had over here. You won't always find that this will divide out with this completely. Sometimes the number that's here and there's another number over here that factor in the second one together, they would multiply to divide out with what's down here. Okay, but that's basically how the Australian method works. And onto the last page here, step 5 here. These are called the special products. Perfect squares, difference of squares, that kind of thing. And so we're going to talk about is perfect squares first of all on the left side of the page here in the top half or so. X squared, and there's sort of two rules here. Plus or minus 2ax plus a squared will factor into x plus or minus a squared. And instead of having the two binomials being different like they were on the previous page, in this case they're the same. So that's why instead of writing x plus a and x plus a, I write x plus a squared. And there's a pattern here. See, this middle term is 2, always 2 because it's squared. 2, and then the product of the a and the x. The a and the x are the things that are being squared here and here. So if we take a look at the first example here, see, it's x that's being squared here, and it's 6 that's being squared here. And you see this middle term is 2 times this x times this 6. And it is. See, 2 times x times 6 is 12x. So that's why this will factor into x plus 6 squared. X is, again, the thing that's being squared right here, and 6 is the thing that's being squared right here. So that's why they'll factor into x plus 6 squared. The only difference in the middle one is that there's a minus here. So the only difference is instead it'll be x minus 6 squared. You see, this is still a plus in the end, because if you square negative 6, you still get a positive. The next one, you see, this is actually 5x that's being squared here, and 3 that's being squared here. And so now there's a minus, so I'll put a minus here. 2 times the 5x. This is sort of how you check and see if this works. And it's 3 that's being squared here. You see, as long as this exactly works out to that, and it does, negative 2 times 5x would be negative 10x, times 3 is negative 30x, then this would factor into 5x, because that's what's being squared here, minus, and you see it's a 3 that's being squared here to make the 9, so it's 5x minus 3 squared. The next one, a little bit bigger, see it's a 7x that's squared at the beginning, and it's a 4y that's squared at the end. And see in the middle, again, the plus here, so put a plus. And so if this 56 is 2 times the 7x times this 4y, then this is a perfect square trinomial. And it is, because you see, that's 14x times 4y does give you 56xy. So this would factor into 7x and then plus 4y, all squared. Okay, now this one, I probably could have put this one on the previous page. This, well, it still applies here. If it starts at a perfect square and ends at a perfect square, it isn't always a perfect square trinomial. So this relates to the last page and this page too. And actually, bring my pen back here. See, this is 3x squared here. And this 4 is 2 squared. So you see, you do the check. So minus 2 times 3x times the 2 on the end from the square. And you see that doesn't work out to negative 17x, because negative 2 times 3x is negative 6x, times 2 is negative 12x. So if this was a 12 here, yeah, it would be a perfect square trinomial, but it's not, negative 17. So so this is how it relates to the previous page. You know, well, maybe it's still factors. Maybe the two factors aren't the same. So we would start looking for, and just get my arrow back, two numbers that add to negative 17 and multiply to 36. 9 times 4 is 36. And so it could be negative 1 and negative 36. But that doesn't work. That doesn't add to negative 17. Well, maybe negative 2 and negative 18. That multiplies to 36, but doesn't add to negative 17 as negative 20. Well, what about negative 3 and negative 12? So you look at all the possibilities. That multiplies to 36, but it doesn't quite add to negative 17. Negative 15 is close, but not quite. And then negative 4 and negative 9, and also negative 6 and negative 6. And none of these pairs adds to negative 17, so it will not factor. So that's how you exhaust all possibilities and check to make sure, does it factor or doesn't it factor. So lastly, we're going to talk about difference of two squares. This is a perfect square, and this is a perfect square, and that's why it's called the difference, because it's the subtraction of the two. And they'll factor into x plus a and x minus a. So for example, now this is 9 that's being squared here. X squared minus 81 would factor into x plus 9 and x minus 9. Again, you can check by multiplying. If you expand this together, you will get x squared minus 81. The next one here, see, it's 6x that's being squared here, and 10 that's being squared here. And so they are perfect squares. But back to the very first example on the first page, notice that there's a common factor here. See, when I wrote down the 6x and the 10, I noticed, oh, 2 goes into both of them. So, in fact, 4 divides into both of these. So it's a good idea to factor that common factor out first. 4 goes into 36 9 times, 4 goes into 125 times. And now, so this is a little smaller. This is 3x squared and 5 squared. And so it will factor into 3x minus 5 and 3x plus 5. Now, no common factor in this one, but if you notice, they are both perfect squares. See, this is 11a that's squared here, and 8b squared that's squared here. And so it will factor into, so it'd be 11a at the beginning of both of these, and then 8b squared at the end of both. So that, again, is the difference of two perfect squares. Yes, two perfect squares. Now, this is a little larger, the last one here, a little larger difference of two squares, because instead of monomials like this that are squared, it's actually a binomial. So we can use, see, it's a perfect square minus a perfect square, so that factoring method is going to work. It just looks a little longer until we get to the end. So, see, 5x plus 3 is what's squared here, so there's going to be a 5x plus 3 here and a 5x plus 3 here, just like, since it was 11a that's squared here, there's 11a and 11a here. Plus, minus, and it's 4x minus 7 that's squared on the end, so a 4x minus 7 at the end of the first, and a 4x minus 7 at the end of the second. And then we remove brackets and collect like terms. Now, of course, with the plus here, no signs change here, but on the end here, see, this is going to change that to minus 4x and then plus 7, and then we can collect like terms. So 5x and 4x is 9x, 3 minus 7 is negative 4, 5x minus 4x is x, 3 plus 7 is 10. Now, another way you could have done this one is we could have squared this, subtracted them, got a trinomial, and done the same kind of factoring that I was trying to do here or on the previous page, and we still would have got 9x minus 4x plus 10. So that would have worked as well. But since I want to demonstrate the difference of two squares with binomials instead. So there's some strategies you can use for factoring. Of course, there are some other ones too, but that is a lot of the common ones. And that's the end of the tutorial.